Welcome back. We are now going to take a look further into section 11.6, where we're going to look at the way in which we write the equation, like for a quadratic function. We're going to write this a little bit differently than what you've seen. So the way we can write a quadratic function. So one of the things that we talked about in the previous video, we talked about the vertex being the point at the bottom of the top of a parabola using h and k. Where in this case, the h is going to serve as the value of the x coordinate for the vertex, and then the k is going to serve as the y value, or the y coordinate, the y value for the coordinate of the vertex. We have a formula that we're going to be relying on here to obtain some critical information to simplify the graphing process here. So let's take a look at how they have this written here. So f of x, which you can also write as y, but we'll keep it from what's in the book here. This is going to be equal to a, and this is going to be times x minus h squared plus k. So in section 11.7, we're going to take the quadratic equations that we've been using up to this point. We're actually going to have to convert them to this form. But in section 11.6, we're going to have the quadratic equations already written in some variation of this. The information we're going to get here is going to be helpful in helping us establish what the axis of symmetry is, what the vertex is, and also graphing the quadratic equation. So one of the things that we're going to have to begin to do is to determine what values of x and what values of x we're going to put in to develop a graph for the quadratic equation, the quadratic function here. So I'm going to go ahead and write this f of x. I'm going to go ahead and write y in its place. And one of the things that you will notice in this formula, or in this representation for a quadratic function, is we have the same letters h and k here. And putting these in is deliberate because from this representation of a quadratic equation or quadratic function, we can quickly ascertain what the value of the vertex is. And this is very handy in the work for graphing quadratic equations. So we're going to go ahead and take a look at problems. And in these following questions, we're going to be asked to do the following. We're going to be asked first, so in the next few questions we're going to be asked to graph. We're going to be asked to label the vertex. And we're going to be asked to draw the axis of symmetry. Now we're asked for these three things, but we don't necessarily have to do these exactly in this order. In fact, what I'm going to recommend that we do first is we're going to go ahead and we're going to label and identify what the vertex is going to be. And we'll see why that's going to help us in a moment here. So again, if you have not done so, the graphs that I'm going to use are going to be in MathBits, but what I've done is to create some additional white space below so I can show all the work in an expanded format for everyone to see. So the first problem I'm going to be given, or we're going to go over, is going to be question 26. And the equation that I'm given for this one is, or the function, is g of x is equal to x plus 4 squared. So if we are looking at the generic form of the equation, remember, what they have for this here is f of x is equal to a times x minus h squared plus k. One of the things we're going to first identify is what's the value of a, what is the value of h, and then what's the value of k. Because once we identify those values, we're going to be able to obtain the vertex very quickly. So, and this is going to be important for choosing our x values to determine how to graph this. So, on the side here, we identify the value of a, h, and k. So we know the value of a, that's the number that's in front, that's going to be 1. The value of h here, this gets tricky. The formula is x minus h. Because we have x plus 4 here, that means that the value of h has to be opposite in sign, so the value of h is going to be negative 4. The value of k, there's nothing here, so we're going to say that the value of k is 0. So among the first things that we're going to do is we're going to go ahead and establish what the vertex is. And the vertex for this is going to be h and k, so it's going to be negative 4, 0. So we're going to go ahead and we're going to take that vertex now and we're going to plot it onto the graph paper above. And there's our point, negative 4, 0. So in looking at this, we're going to see that the value of a, that this is going to be positive. Now in this particular case, what this is going to mean is that having a positive value of a, just like when we have ax squared, when that's positive, is going to cause this parabola to go in an upward direction. And since this is the vertex, we know this is going to be the bottom. So we want to choose values of x that are going to give us a nice shape of the parabola that we can fit comfortably on the graph. So we're going to go ahead and we're going to generate a table of numbers to put in to effectively graph this parabola nicely. So I have x here. My function is x plus 4, the quantity squared. And then I'm going to put y for this, as I can write this as y equals x plus 4 squared. And I'll go ahead and label my axis x and y. On the computer, you may see the axes labeled as x and f of x or g of x or h of x or y. You can treat them all the same. So what I'm going to do here is I want to create a place to put 5 points. But in doing so, I want to make sure, since the vertex is going to be in the center, I'm going to go down 1, 2, and 3, and I'm going to put my negative 4 here. So I want to pick 2 values just below negative 4 and 2 values just above negative 4. So for this purpose, I'm going to pick negative 5, negative 6, or it's negative 6, I should say, negative 5, negative 4, negative 3, and negative 2. These are the values that I'm going to put into the function here. So this is going to be negative 6 plus 4, negative 5 plus 4, and I'm going to square these, negative 4 plus 4 squared, negative 3 plus 4 squared, negative 2 plus 4 squared. So now notice here it doesn't say I have a place for work. If you, and because I'm trying to keep these notes fairly compact, if you need to, you may want to spread this, maybe a line or even 2 lines underneath if you want to show additional work or be able to do the additional work yourself to make this easier for you. So negative 6 plus 4 is negative 2. Negative 2 squared is going to be, or excuse me, yeah, it's going to be 4. Negative 5 plus 4 is going to be negative 1. Negative 1 squared is going to be 1. Negative 4 plus 4 is 0, and 0 squared is 0. Negative 3 plus 4 squared, that's going to be 1. 1 squared is 1. Negative 2 plus 4 is 2, and 2 squared is 4. So now I have the points negative 6, 4, so this is, again, negative 6. This is going to be negative 5. Sorry for the confusion on that. Negative 5, 1, negative 4, 0, negative 3, 1, negative 2, 4. And we're going to go ahead and we're going to put those points down. So this is going to give us negative 6, 4, negative 6, 4, so we're going to go negative 6 and then up 4. Negative 5, 1. Negative 4, 0. And what is this? This is the vertex. Notice that we put negative 4 in, we obtain the same value here. That's no coincidence. That makes perfect sense. Negative 3, 1. And then negative 2, 4. So now we've got this here. And now we have the graph of our parabola, as was indicated. So now we have the graph for this. We have the vertex. Now we're looking finally for one more piece. We're looking for the axis of symmetry. So the axis of symmetry is going to be a vertical line. It goes to the vertex. So all we see when we look at this here is find the vertex and then just draw a line straight up and down through it. The way we write this equation there are two questions to ask. And I encourage you to go ahead and write these questions down. And, okay, or actually just one question. At what value does the line cross the x-axis? So this crosses the x-axis, okay? The axis of symmetry is always going to cross the x-axis, so it's going to be x equals something. Where does it cross the x-axis? It crosses at -4. So the axis of symmetry for this is going to be -4. So we have the three parts to this question now. It asks for three things. The first thing it asks for the graph of the function. We have that here. The next thing it asks for is a vertex. We have that here, -4, 0. And then the last thing it asks for is the axis of symmetry. So we graph the axis of symmetry and we can express the function of this line as x equals -4. The reason we can express this as x equals -4 is that every point on this line, the x value is going to be -4. This is -4, 0, -4, 1, -4, 2, -4, 3, -4, 4, -4, -3, -4, -4, -4, -5, -4, -8. All the x coordinates of all those points have the value of x in -4. This is why we can write the equation of that line as x equals -4. We're going to find a shortcut to identifying the axis of symmetry without even having to do the graph, but we need to do one more problem to make this a little easier to see. So let's go ahead and we're going to take a look at question 30 and let's see what we can get from that. So we have 30 now, and 30 is going to be f of x will equal negative the quantity of x minus 1 squared. So it doesn't look too bad, but first thing we're going to do is we're going to identify the value of a, h, and k. So for the value of a, we have a negative in front of this, so the value of a is going to be -1. So this is going to be negative, so we anticipate that this is going to cause the graph of the parabola to open downward, be a frown. H is equal to, let's see, we have negative h, so this is going to be equal to 1, not -1. The negative is part of the formula here. And then finally the value of k, we still have no k yet, so we're going to go ahead and let that value be equal to 0. So let's go ahead and take a look at this now. The first thing we're going to do is go ahead and identify the vertex. And we get the vertex from the value of h and k, and that's going to be 1 and 0. So we're going to go ahead and put that point on the graph now. And then we're going to create a table of values so that we can graph this parabola. So remember, as you create your table of values for this, so I can write this as y equals negative the quantity of x minus 1 squared. I'm going to write this as x negative x minus 1 squared, and then y. I want to create a place to put 5 values. In the middle is where I want the x-coordinate of the vertex. So I'm going to take the x-coordinate vertex, which is 1. I want 2 values below, 2 values above, so this will be -1, 0, 1, and, or excuse me, 2, and 3. So one thing you may want to do when you're doing this, work backwards from 1, write 0, -1. Work forwards from 1, write 2, 3. That may make it you less likely to make a mistake. Here's one where you're probably going to want to save some extra lines, maybe 1 to 2 extra lines underneath each of these substitutions for your work. Like I can do this work in my head, but you may not necessarily be able to do that. And the beauty of using a flipped classroom is at least you can make these accommodations for yourself in planning this as you go along. There. Just making sure you're awake. So, in this question here, we're looking to generate 5 points. We already have this one here, so this one should come out to be, let's see, 1 minus 1 is 0, 0 squared is 0, that's fine. We have 0 minus 1, so what I'm going to do is I'm just going to cover up each negative as I do the calculation. 0 minus 1, that's going to be -1. -1 squared is 1. Now that we have 1, we have to negate it, so it's going to be -1. Negative 1 minus 1 is going to be negative 2. Negative 2 squared is 4. Negated, negative 4. 2 minus 1 is 1. 1 squared is 1. Negative 1. 3 minus 1 is 2. 2 squared is 4. Negate that. We come up with negative 4. So here are the points that we're going to go ahead and put to paper now. So we have negative 1, 4, 0, negative 1, 1, 0. Again, we get that same point. Here's 2. Oops. And what am I doing? I'm not putting these backwards. So ixnay those points. So here's going to be negative 1, negative 4. Here's going to be 0, negative 1, 1, 0, 2, negative 1, and then 3, negative 4. And you'll notice, as we talked about earlier, because we have that a value of negative 1, that the parabola now is opening upside down. So we've achieved two things so far. We've gotten the vertex, and we've graphed the parabola. And remember, we use the vertex, or the x value of the vertex, to find the middle point for our table of points in order to successfully graph the parabola. And in case any of you are wondering out there, do I want to see the graph in your homework? Yes, I need to see the graph in the homework. I need to see a table of values that you use to generate the graph. If you don't have that, I will not give you credit for homework. So my expectation is that your homework, you should have the graph. If you generate that fairly generically, I'm okay with that. But you should have 5 points. They should look fairly concise in the, in where they should be. You need to have your parabola going in the correct direction. All of these things, because this is what you're going to be expected to do on your test when you take it in class. So we have the vertex, we have the graph with the points with it, and now we have the axis of symmetry. So let's go ahead and identify that. So the axis of symmetry, I'm going to find the vertex and just draw a line through that, going up and going down. And I notice here it crosses the x-axis. Where's it crossing the x-axis? It's crossing it at 1. So I'm going to write the axis of symmetry as x equals 1. So I mentioned that I would show you a shortcut for identifying the axis of symmetry without even needing to use a graph. Once you identify your vertex, all you have to do is let x equal, for the axis of symmetry, let x equal the x value of the vertex. Here the vertex is negative 4, so the axis of symmetry is x is equal to negative 4. Here the vertex is equal to 1, 0. The x coordinate of the vertex is 1, so the axis of symmetry is x is equal to 1. And this makes sense because the axis of symmetry always goes through the vertex. So this is entirely consistent with everything we talked about before. So you're hearing a lot of new vocabulary. You're going to kind of hear me say the same things over and over again, but it's important to get the regular exposure to this so that you develop the connections between these concepts here. So let's go ahead and go to the next round of problems of this. We're just going to cover one or two more of these and just show you how to kind of work through when we have fractions of the problem. So we'll go ahead and take a look at, let's take a look at problem number 30, let's look at 30, let's see, and it's one of your homework questions, but it's really one that I want to start with. I think 39 is a good place to start because this has fractions involved in this now. So let's go ahead and take a look at this one. 39, this is going to be f of x is going to be equal to 1/2 x minus 1 squared. So let's just establish the value of a, h, and k. A is equal to 1/2, h is equal to 1, and then k is equal to 0. So this actually is a nice one to follow up with because we can take a look and compare the difference between the graph of this and the graph of the other one. One of the things you should notice right away is that the vertex is equal to 1, 0. And we're going to put that here. However, when we come up with our table of values for the graph, and I just need to establish how far I can go down. When we look up the when we go to create a table of values for the graph, we do have to pay a little bit of attention to this, because in an ideal world, we're looking to try to get whole numbers that we can plot, especially for y. So here's going to be our x. Here's going to be 1/2 x minus 1 squared. And then here's going to be the value of y. So we're going to go ahead and write this again as y equals 1/2 x minus 1 squared. So I'm going to pick 3, 4, 5 values. I'm going to pick one for this. But here's what I want to do. I want to pick values here that are going to give me, when I square these, even numbers, so that when I take half of an even number, that's going to give me an even number too, so I plot this. So for example, if I put 0 in here, if I 0 minus 1, that'll give me 1. 1 squared is 1. I don't want to plot 0 1/2. So what I need to do is to put numbers in here that's going to give me an even number. For example, let's say I put 3 in. Or let's try 2. 2 minus 1 is 1. 1 squared is 1. Half of 1 is 1/2. 2 doesn't work. If I put 3 in, 3 minus 1 is 2. 2 squared is 4. Half of 4 is 2. That's a good one. So what it's going to turn out to be, let's try 5 now. 5 minus 1 is 4. 4 squared is 16. 16 divided by 2 is 8. So it looks like we seem to have to go up or down by 2's. So 1, 3, 5. Let's go down to -1, -3. So my guess is going to be that we have to increase these by 2 or decrease them by 2 in order to get whole numbers for the values of y to make this more easily plottable. So this is something that you'll have to play with, experiment with. I would say as a general rule, if you look at the number that is down here, whatever number you have here, you want to increase it by what the denominator is. If the denominator of this is 2, you want to increase by 2. If you had a denominator of 3, you want to either increase by 3 or you want to decrease by 3. If you had 7, you want to take whatever number you have for your vertex and then increase by 7 or decrease by 7. So that is a really important rule. Star what I am saying. This is really key. You'll hear me refer to it again later as we expand to do more problems. So let's go ahead and let's tackle this problem. So we are going to, let's see, have 1/2 times -3 minus 1. I'm going to close that now. 1/2 -1 minus 1 squared. 1/2 1 minus 1 squared. 1/2 3 minus 1 squared. 1/2 5 minus 1 squared. So this one here is going to give us, let's see, -3 minus 1. This is a minus 1, guys. That's -4. -4 is squared is 16. Half that will be 8. -1 minus 1 is -2. -2 squared is 4. Half of 4, 2. 1 minus 1 is 0. That's going to be 0. Now, one thing you should notice by now, but double check your work. 3 minus 1 is 2. 2 squared is 4. It's 2. 5 minus 1 is 4. 4 squared is 16. Half of that is 8. You should notice that there's going to be symmetry here, and that should make sense if you do this properly. You have to make sure that these numbers are increasing by 2. The vertex is in the center here. If you have these numbers increasing by the same amount and you have a vertex in the center, you should begin to notice the symmetry in numbers that we talk about, that we see graphically. Let's go ahead and graph these points that we have now. And let's see, we've got the point -3, 8. It's going to be up here. Then we've got the point -1, 2. Then we've got the point 1, 0. We have that. Then we have the point 3, 2. Then we have the point 5, 8. So when we begin to compare the graph of this quadratic function with the graph of the previous one, you'll note that the only difference in the function itself is that a is equal to 1/2. In a being equal to 1/2, where in fact a is less than 1, it has the effect to widen the graph of the quadratic function. So when you have a value of a that's going to be less than 1, it's going to have the effect of widening the function. And the smaller the value of a, the wider the graph of the quadratic function is going to be, or the wider the parabola is going to become. So the last thing we need to do is we need the axis of symmetry. Going back to what we said before, all we need to do is put that through the vertex, draw a vertical line, and since we know the vertex is 1, 0, we can rely on this and just simply say the axis for the axis of symmetry that x is equal to 1. And that's it. So we've identified our vertex as 1, 0. We have the 5 points to create our graph of the parabola, and we have the axis of symmetry of x being equal to 1. So we're going to now step this up a little bit with our next problem, where we're going to begin to, or at least in the next video, where we're going to begin to look at values of k now that are going to be all over the place. So it won't be just k equals 0, but we're then also going to be asked to identify if it's a maximum or a minimum, and then also find what the range of the graph of the parabolic function is going to be. That's coming in the next video.